Almost afternoon, everyone. My name is Yehonathan Barnea. I lead the demand forecast.ai product at Pecan.AI. Very happy to be here with everyone, talking a little bit more about demand forecast. So we're going to discuss how to get value from demand forecast, specifically AI demand forecast. Where should we trust it? When should we be a little bit more cautious? How should we think about it in a more collaborative way? I don't think anyone has to say more AI to understand that AI is everywhere, right? We even have it in our name, so then we know that we're doing AI. But the truth is, there's a huge difference between thinking about AI, experimenting with AI, and actually getting value from AI. That's one of the biggest challenges companies have. And even though there's a lot of very optimistic predictions, like Gartner's prediction that in a few years, almost everyone's going to use an AI-driven demand forecast, using or trying out AI or machine learning models does not necessarily guarantee to see value. And today we're going to talk about how to make sure that process is significantly more coupled with actually realizing value. So why even we're talking about AI specifically in the context of demand forecast? First and foremost, demand forecast is a critical use case for anyone with a large and complex supply chain. It was recognized by many years ago even, as a fantastic use case for machine learning and AI, mostly because it is about predicting the future, which AI does well, and also because it's in an ingrained process most companies have some sort of a critical knowledge in that doesn't require a great deal of change management. In addition, we're going to talk about the advantages of using machine learning and AI in this specific context, but as a use case in general, a tiny improvement for a large company in forecast accuracy can have a tremendous impact on the bottom line, service level, inventory, working capital, and so on. I think everyone knows it. The question is, how do you make sure you're actually going to get it? What are the two biggest drivers we see for value in a demand forecast, and specifically in an AI-driven demand forecast? So the obvious and clear one would be improving accuracy. Accuracy leads to less over and under stock. The second, which probably is a much more debatable and interesting topic, is reducing manual effort or automation, or getting more with less resources. Those are things that AI is great at, and that's why it's a very important thing that will recognize what is the needed lever for every situation in your demand forecast, and how can you make sure that you're addressing it in the right way. So before we can understand if we can trust AI, which is a big word, we first have to figure out, number one, what is AI in this specific context? Number two, where would AI excel? And where would it have some limitations that people still need to close the gap? So just for the sake of the context, when we say AI in demand forecast, we typically use or typically think about using machine learning algorithms. Their advantages and their benefits is that they ingest complex and large sets of data and build a relatively robust and accurate forecast. Okay, that's the high-level use case of AI in demand forecast. There's significantly more capabilities that could be added for automation, for analytics, for data cleansing, and so on and so forth. However, that's the main difference between a relatively simplistic demand forecast that will use fewer data resources and assets, and a machine learning or AI-driven forecast. Where does AI excel? Large and complex data patterns that are not intuitive, not clear, may not have very obvious linear relationships. Okay? Models tend to be more consistent, and more complex models will be able to deal with a complex data pattern. However, they're not perfect. They're only as good as the data that they were exposed to. And if that pattern happens for the first time, there's a good chance AI is still going to miss, right? So one of the most important tasks is to identify where can we trust it and why, and where we need to be a little bit more cautious. So for example, in places where nuance plays a lot of importance, where human chatter where emails or phone calls or something that is very hard to institutionalize into a data set, that could be an opportunity for still using context that is not readily available for AI today. Maybe it's going to change in the near future, but today there's still a limitation about data capture and the ability to use some of those data inputs into a model. And then at the end of the day, there are modeling situations where the models are just not good enough. Maybe because the signal is not there yet, maybe it's a new product, there's multiple reasons. But again, the challenge would be, how do we identify where you can trust these models and where we shouldn't trust them in face value? Now, most organizations don't measure trust because it's first very hard to even define trust. Most organizations measure forecast accuracy or some type of a critical metric, right? Let's just say that your forecast accuracy is 92%. Is that good, bad, mediocre? I know a lot of people who would be very proud with having a 92% forecast. But maybe that's not the exact question we should ask. Maybe we should ask a little bit more of a nuanced and complex question. Because things like single metrics typically miss the more complex story, and at the end of the day, the world is much more complex than just one metric could actually represent. When we think about measuring trust or measuring how our forecast is performing, we need to think about multiple dimensions. For example, bias. Are we on average over or under predicting? One of our customers that recently started to work with us is a glass manufacturer. One of their biggest challenges is that they couldn't really shut down their manufacturing facility. Inherently, they have a huge risk for overproduction. The question is, how do you make sure you're biasing towards overproduction in places that hurt you less? MAPE, or forecast accuracy. It's a common metric to identify and measure accuracy. But is it always relevant? What are you trying to compare it to? And then MAPE could mean different things for different people. Are you measuring MAPE for lag 3, for lag 1, which means 1 month ahead, 3 months ahead, 6 months ahead? The answer depends in your specific supply chain considerations. Maybe some of your products have a long lead time. You should look at longer MAPE. Maybe some of your products have a very short just-in-time strategy. Therefore, shorter MAPE is significantly more relevance. At the end of the day, the bottom line is there isn't just one bottom line. There's a complex and nuanced story for each one of your products. The more you segment and understand the complexities of your supply chain requirements, and the more metrics you would use to understand them, the more likely you can start trusting these models. So we want to make sure that we're shifting from having one metric that everyone is very proud of. At the end of the day, it's easy to say this is our forecast accuracy, into more nuanced types of a conversation, right? What is fitting my forecast? Am I measuring everything I can measure? What is the methodology I'm using? Am I capturing seasonality and trend? Am I capturing the short-term demand spikes? And are we preparing an understanding of how to leverage our forecast when things don't go according to plan? The more we segment, the more we try to understand the different nuances of how our portfolio and products behave, the more we can leverage advanced models and make sure that human attention goes in the right place. We can think of where are the segments in my forecast I can trust completely. I don't need to touch unless something tells me I should. What happens with my highly seasonal products? Can I look at them with the same perspective in the low season and in the high season? What is important for me to measure? Maybe I'm going to have different metrics or different way of looking at my forecast at the low season or in the high season. Am I launching new products? When can I reliably look at the forecast and make decision based on them, as opposed to having assumption-based forecast or even a conversation with the customers at the end of the supply chain? All these things will help us position and have a quicker and sharper view on how to use our forecast. So what do we see? When you look at our portfolio of customers who are working with us, we almost always see a very large potential of reducing human interference in the forecast. It varies across industries, but we've seen somewhere between 60 and 90% of the portfolio that could be almost fully automated, which means those could be no-touch products. Obviously, these are large averages. It's not going to be exactly the same in every industry, but the important thing is that there's almost always an opportunity to identify this is where I can reduce my attention, this is where I can let the machine do the work. What are we seeing as good performing accuracy perspectives? And I'm just contradicting myself because I'm trying to give one number. When we think about good accurate forecast, and here I'm just using lag3 monthly MAPE as a benchmark metric, we are seeing great teams who are leveraging AI forecast being in the low teens from the MAPE perspective, which means highly reliable, very good potential for automation. And then when we go to the right-hand side, accuracy in the 30s or even above are typically not achieved using an AI forecast. It means they're using time series forecasting or some type of a forecasting mechanism that is not able to extract enough signal. Obviously, in some cases, even an AI forecast is not going to achieve fantastic results. However, the objective of using a more intelligent forecast is to improve and get above your existing benchmark. It's not like you can predict everything perfectly in every type of a scenario. One of the hurtful things or the missed opportunities we do see is that even if sometimes the forecast gives a very good opportunity for automation, teams are sometimes not confident enough to actually adopt and use the forecast as is. In this case, and this is an example from one of our largest customers, before we introduced more and more trust mechanisms, what we see here is that 82% from the volume perspective of their portfolio, we designated as no touch, meaning the forecast is very reliable, very steady, and could be adopted in an automated fashion. However, the planning team didn't have significant or enough confidence to actually adopt the forecast. When they intervened, they led to a negative impact. The bottom line is that they lost somewhere between 1% and 5% over those months, which is a shame because that hard work as far as getting the forecast into a very mature place was already invested and couldn't come to fruition. At the same time, the smaller segment we call touch, meaning the model thinks that the humans can add value, was actually accurate, which means the planners can spend most of their time in improving the performance of the touch segment, improving value as we can actually see that they do, and then stop touching unless they have a very good reason in the no touch segment, giving them a huge boost in accuracy almost immediately. So when we intervene, we people intervene when we don't need to. We increase the bias, we increase the noisiness, and we hurt accuracy. The critical thing would be how do we identify in a robust way places where we can reduce the level of interference, increase the level of automation, and reap the benefit of the hard work of the AI forecast we helped build. So best performing teams try to identify the low touch area as a policy after they gain enough trust and implement enough tools, try to minimize the amount of touching and manipulation in the low touch segment, focus on the high touch, where they can increase value in a meaningful way, where they know the model is not seeing something clearly, where they have an advantage over AI. That way, accuracy and stability can boost both from increasing accuracy on the high touch perspective and reducing the amount of lost opportunities on the no touch segment. Now, this is something that we hear a lot, the concern that AI is going to replace planners. We don't see that happening today. At the end of the day, there's significant amount of value that could be extracted by using planners in a much more focused way. Instead of trying to catch everything and then having a mediocre result over a large number of product portfolio, focusing on where they actually add value, and then trusting and figuring out how to improve the model elsewhere. A critical thing that we are always being asked is how hard it is to get started. Is this a year worth of a project? I don't have my data ready. I don't think we have the right resources internally to start this. At Pecan, we've developed an approach of let's try to get into a very quick proof of concept within weeks that is going to give you the flavor of what does it actually mean to use a machine learning model, so that you can make a conscious decision. Do I want to scale this capability? Do I want to implement it across my broader portfolio? To make those things effective, we think these are the critical components to define. Have a clear success criteria. What are you trying to achieve? Are you trying to get more automation in your forecast and reduce the amount of manual effort? Are you trying to increase accuracy? In what segments of your portfolio are you trying to increase accuracy? Does it make sense? Are you trying to use multiple data sources that you were not able to do before? Are you trying to use external data? And so on and so forth. Define those things clearly. Define the clear metrics that are going to be helpful for you to make decisions in the future. If you're not measuring FVA or forecast value add, start measuring the impact of the manual intervention of the forecast to see, are you actually improving the forecast or not? And where specifically is that the case? We've constructed a relatively quick process of getting from hypothesis and ideas into an actual project. In about 12 weeks, we are going through a journey that defines clearly what you're trying to predict, how valuable are your existing data assets, and how can we move very, very quickly from idea to a production-ready model. We have the benefit of focusing on one thing and one thing only, which is demand forecast models. Therefore, the methods and the technology we've developed allows us to do these things relatively quickly and giving decision makers the ability to see with their own eyes what is the potential without running a very expensive and long project. So to sum it up, AI creates value when it's used properly, when we know where to leverage it, in what circumstances is it trustworthy, and where does it still need a lot of human guidance. The combination, the right balance, would be a critical component for achieving success with AI in demand forecast. If you want to learn more, we're going to be just outside here at booth K. Feel free to come in and learn more if you wish, and I want to open up for questions. Just a second.
Hi, thank you. One of the questions that I have is that obviously one of the big challenges is try to convince the business that you're going to be having a black box that is going to be doing your forecast. Mm-hmm. So, in practice, how you come and face that challenge when working with your clients?
Yes. So the black box challenge. So first, I don't think the business necessarily understand the algorithms of exponential smoothing, and it's not like all of them are mathematicians and suddenly they're not aware. But jokes aside, at the end of the day, trust comes from as the most level of context that we can provide. So first of all, understanding what data is being used and what data is not being used. Second, explaining at the business level, as the business-friendly level, what are the data manipulations that the system does automatically and exposing them as much as possible. Doing training and enablement about how would machine learning algorithms work, what you can get out of them and not, and then adding a layer of explainability that shows you drivers of the forecast. There's a very deep level of explainability you can still get from machine learning models. It doesn't necessarily mean all of them have a tremendous amount of intuition. At the end of the day, there's always a trade-off between simple explainability like you will have in, let's say, econometric models, which thrive with explaining the world but may not actually perform well, and models that may have a more complex mechanism from a technical perspective, but at the end of the day will yield higher accuracy. I don't think there's only one factor. It needs to be exposing the teams who are involved in the technical capabilities as much as you can, the data. And at the end of the day, I don't think you can beat empiric data. So seeing accuracy and accuracy over time, at the end of the day, that's very hard to argue with, but it requires a process of trust development. You have budget for 2 questions?
So linked to the first question, so these, when you're trying to implement something like this, is normally supply chain driven, right? And then, so based on that, do you recommend the definition of baseline in terms of data, what you're going to be using in terms of historical data, is it something that needs to be done cross-functionally, or it needs to be owned by the supply chain only?
Tough question. I think it needs to be a collaboration. I think the friction point starts because the supply chain organization typically doesn't work at the same level of granularity as the business, right? So if you have an IBP process that's being managed at the brand or some type of a high level where the planners have the burden of translating money into units and those things don't necessarily tie in together, then we want to help the planners have as much context as possible. I think a critical key is to represent within the forecasting process what is the shared language. For example, what are the drivers or building blocks that the model is aware of that you can actually incorporate into a model. If you think about an IBP process, it's an assumption-driven process. It doesn't mean that it's not relying on data. It's just not necessarily relying on data at the same level of granularity as a demand forecast. So I would say the first thing I would try to do to kind of build that connecting tissue, let's make sure that any building block or driver that is being used in the IBP process or SNOP today, that we can incorporate into a predictive model. Let's do that. And let's add or keep aside everything that is not really structurally feasible to put into a model. If there's a good capture of historical data of your distribution, of your marketing spend, of your retail POS, and so on and so forth, go ahead. This is the advantage of using AI forecast. You can incorporate those things. However, I think the places that cause a lot of teams discomfort is when they're actually met with, I don't really have a really good way analytically to demonstrate this building block. It's an assumption. Therefore, the model can't just identify an assumption. It needs to see facts. So transparency in what's there and what's not, and then performance, because sometimes some of these building blocks don't really meet reality when you look at seeing their and measuring and seeing their actual incremental effect. I hope I answered the question. Okay, if you don't want to ask any questions in front of everyone, feel free to come and see us at our booth. Thank you so much.